Todos nós temos visto recentemente imagens do colapso do duplo refletor do radiotelescópio da URSI, que, enfim, caiu e acabou por destruir também o refletor. O próximo trabalho anda nesta área da detecção, neste caso de resíduos espaciais, o projeto Atlas, e vai ser apresentado pelo João Pandeirada. O João Pandeirada vem aqui defender as cores da Universidade de Aveiro e também do Instituto de Telecomunicações do Polo de Aveiro. É também um estante de doutoramento, penso que estará em início, e portanto vem também aqui partilhar aqui o seu trabalho sobre o Atlas. Portanto, João Pandeirada, obrigado por ter vindo, obrigado pela sua participação, pode começar quando quiser.
Okay, first of all, good morning to everyone, and thank you for having me here to present my work. So I am here to present Atlas, the Portuguese pilot radar system for the detection of space debris. Since the beginning of the space age in the 60s, that humanity has been deploying more and more objects to space that are being orbiting our planet. And due to more and more space-related activities, the number of objects that is in orbit has been increasing exponentially, as you can see in this graph here from the 2020 ESA's annual space environment report. And to give a more illustrative idea of the number of objects around our planet, this is a simulation made by ESA that shows the number of particles with a length higher than 1 millimeter. And as you can see, this poses a big problem for our activities on space. And in order to tackle this problem, the major space agencies like NASA, ESA, and the USST are trying to develop systems and solutions to solve this. So what is the USST? Simply put, it is a group of European countries that are working together to establish a space surveillance and tracking service. What this means is that each country has a number of telescopes and radio telescopes that they use to survey and track the objects that are on orbit, and together we can establish a service that can provide collision avoidance in order to keep safe the satellites and the structures that we have in orbit, and to help on future launching missions. Analysis of objects that are decaying and that are re-entering the atmosphere, and the analysis of objects that are colliding with each other, fragmenting and creating new objects. So Portugal is a member of the USST with both optical and radio sensors, and we are the ones responsible for the radio sensors. And the Instituto de Telecomunicações is a linked third party to the Ministry of Defense regarding this matter. Regarding the infrastructure of our system, what happens when USST wants to use our sensors in Portugal? It interfaces with our National Operations Center that we have in Açores, and the Açores NOC tasks and talks with our radar system, which is located in Pampilhosa da Serra in the AirPop station. The AirPop station houses all the infrastructure needed to operate the radar system. And we also have a remote connection, highly secure and dedicated to Instituto de Telecomunicações in Aveiro, where we do all the research, development, and maintenance of Atlas. Regarding the specifications of the radar system, here you can see some of the backend components of the system. It is a monostatic pulse tracking radar, which means that it only uses one antenna both for emitting and receiving. Because of that, it emits pulses to the objects in the atmosphere, and then waits to receive the echo pulse in order to detect and characterize the objects. It has a peak power of 5 kilowatts, working at a carrier frequency of 5.56 gigahertz. And it uses power amplifiers based on gallium nitride transistors. So it's solid state power amplifiers. Which means that they are very efficient and very easy to upgrade. So if we need more power in the future, we can easily upgrade that. All the waveforms that we emit can be synthesized in the digital domain, which is very useful to prototype new waveforms. We use a fully coherent receiver with a 50 megahertz of bandwidth. With these 50 megahertz of bandwidth, we have enough bandwidth to do all the signal processing fully in the digital domain. And we expect to measure objects as small as 10 centimeters squared in radar cross-section, at a maximum distance of 1,000 kilometers, and we expect to have measurements with in range with an error below 0.05%. Finally, I want to talk to you why Atlas is important for Portugal, since I define it as a unique platform for research and development. Why? Well, most of the radar systems that are out there, they are quite old and they use proprietary systems. They are very fixed and not easy to upgrade nor to implement new techniques. Because of that, we developed a system that uses commercial off-the-shelf components and is based on an open system philosophy, which makes it easy to replicate, upgrade, and disseminate the work and the knowledge. And since all the waveforms can be synthesized and the echoes can be processed all in the digital domain, it makes us able to imply novel and dynamic signal processing techniques, use the advanced waveforms, which, as I said, is not possible in older systems, which are quite fixed and use very well-established waveforms and techniques. So because of that, and because our system will be in operation and will be working in the future soon with the USST, it is very important to transfer the knowledge on both operation, research, and development of radar systems to the national industry. So this is the end of the presentation. Thank you.
Thank you, João. João, we heard about the Azores Operation Center very recently, but most of us don't know about the Pampilhosa Space Observatory in Portugal and the connection with Aveiro. How is that working? How is that all put together working? And could you give us a word about this observatory, space observatory in Pampilhosa da Serra?
Yes, yes.
How many antennas? Where is it exactly? And how is connected to Aveiro?
Okay, so basically the AirPop station in Pampilhosa da Serra, it has two antennas, and until now they were basically used to radio astronomy studies. And this is included in the Engage SCA project, which is housed and where we have a big team working on the Engage SCA project, which is a project that includes radio telescopes all over the world to do radio astronomy studies. And this project is also housed in the Instituto de Telecomunicações in Aveiro. And basically the radar is an upgrade to one of the antennas, which will be used not only for the radio astronomy studies, but also to the surveillance and tracking of objects. And this connection is made by a dedicated optical fiber connection that we have in Pampilhosa da Serra for the station. And we use encrypted, and it's an encrypted connection, highly secure, because we already have that for the Engage SCA infrastructure. So the system, the Atlas, is also on top of that infrastructure that we already have. So we have remote access to everything, basically that's it.
That's good. João, you told there are, I can see that there are tens of thousands of space debris actually. You talk about tracking those. How is it possible with this system here to track all those space debris, so many, and how is it possible to track all these debris?
It's not possible to track all of them. What is possible to do is to, because their orbit is changing, refreshed every day. What basically EUSST is responsible for is to understand, these objects, for instance, will pass in the observable range of the Pampilhosa radar in a time window in a specific date. So they say, okay, go task that object. So we emit pulses to this object. It reflects the pulses. We measure the distance, the time of arrival of the pulses, so we know the range, the distance, and then since we know where we are pointing to, we know exactly the position of the object on space, and then we retrieve that information to EUSST. Since the objects are changing their orbits slightly every day, by refreshing these catalogs every day, by tasking all the radar sensors or optical sensors around the Europe as ours, we can update the catalog and have the most refreshed version of it every single day.
Okay, that's amazing. José Pedro, would you like to make any?
Yes, I'd like to know how the system performs with objects with different sizes. So the performance is better with bigger objects or with small objects. Do you have any idea about the performance and the resolution of the system in terms of detection?
Yes, if we in the radar world, we don't talk exactly about the size, the geometrical size of the object. We talk about the radar cross section, and the radar cross section is a measurement of how well the object can reflect the electromagnetic waves, and that depends on the number of scatterers that object has, the distance between the scatterers, and the materials of the object. So if we talk about the radar cross section, which is measured in area, in centimeters squared, for instance, for higher radar cross sections, we'll have better signal to noise ratios. So we will detect with more precision the distance, and the confidence on the measurement will be better. For lower radar cross sections, it will be worse. So if we talk about that measure, the radar cross section, yes, the bigger the better. But it's not direct with the geometrical size, because, for instance, in the case of the space debris, we could have because they fragment in random ways. We can have objects that are very high, but because of their materials, they don't reflect that much electromagnetic waves. So in case of space debris, is a bit chaotic. It's well established for instance, for airplanes or for military aircraft. It's well established, but for space debris, we need to be careful with that, because it's not trivial at all.
Okay, thank you very much for your clarification.
Okay, thank you, João, for your presentation.